Hello everyone, this is Pankaj and I welcome you all to new day, new question series. So once again, one more question we have on the series. Let's say what does this question is saying. So basically the question is saying two parallel plate capacitors C1 and C2 each having capacitance of 10 microfarad are individually charged by a 100 volt DC source. Okay, capacitor C1 is kept connected to the source and dielectric slab is inserted between the plates, while the capacitor C2 is disconnected from the source, that is battery, and then that dielectric slab is inserted. After some time, the capacitor C1 is also disconnected from the source and the two capacitors are finally connected in the parallel. The combination potential of common potential of the combination they are asking, and dielectric constant they have given as basically 10. Okay, so we have condition of the two parallel plate capacitor, they are connected in the parallel. So let's first draw the diagram. We have these two capacitors which are connected in the parallel. Name of one capacitor is C1 whose value is 10 microfarad. Second one also have the value of the 10 microfarad. They are also connected with the battery having potential of 10 volt, and one more thing they are saying, like we are basically inserting the dielectric in between the plates of capacitor. Let's first write down the values. So value of C1 is basically how much they have given, 10 microfarad. After that, voltage how much we have, 100 volt. So of course the value of charge, which is Q, is equals to C into V. It will be 1000 microfarad. Similarly for second capacitor, again it is 10 microfarad, battery 100 volt, 1000 microfarad of charge. So micro, not microfarad, it should be microcoulomb because we are writing charge. Okay, so charge we have here 1000 microcoulomb, and this one is also 1000 microcoulomb. So this is the given data we have, which they have mentioned in the question. This one is capacitor C1, whereas this one is capacitor C2. Okay, this is the initial condition we have. Now finally what we are doing, capacitor C1 is connected to the source and dielectric slab is inserted between the plate. So condition for capacitor C1, as well as we will write condition for capacitor C2, because they have given the condition both for C1 and C2. So for C1 what they are saying, C1 is basically connected to the source. It means we can say that battery is connected when we have inserted the dielectric slab, and dielectric slab inserted, whereas for C2 it is disconnected from the source and then dielectric slab is inserted. So battery is disconnected and dielectric slab inserted. So we know that whenever battery is connected, while inserting the dielectric slab, voltage remains constant, whereas when battery is disconnected while inserting dielectric slab, charge remains constant. That's why, and one thing is for sure, like whenever we insert the dielectric slab, capacitance increases k times. Similarly for C2, which will be C2 dash k times of C2. Value of k is 10, value of C1 is 10, it will be 100 microfarad. Similarly for the C2 dash also 10 into 10, which will be equals to 100 microfarad. Now voltage will be common, like constant, V1 dash, it will be 100 volt only, it will not going to change, whereas here charge, that is Q2 dash, will be constant, that will be 1000 microcoulomb. Okay, so we got the value of C1 dash, we got the value of V1 dash. Let's find the value of Q1 dash. So we know that Q is equals to C into V. Q is equals to C into V. Our voltage is constant, so Q and C both are directly proportional. So if your capacitance is increased k times, Q will also increase k times. That's why the new value of Q1 dash will be 10 times of old value of Q1, that is 10 into 1000, that will be 10,000 microcoulomb. Whereas for voltage we know that again C is equals to Q by V. Here our Q is constant, and second thing we want basically C is equals to Q by V. We know that here our Q is constant, so C will be inversely proportional to V. So new voltage will be, that will be basically your V2 dash will be whatever old voltage we have, it will be divided by K, that is 100 by 10 will be 10. Now what they are asking, now they are saying after some time capacitor C1 is also disconnected from the source and two capacitors are finally connected in the parallel combination, that is C1 dash and C2 dash both are connected in parallel. C1 dash and C2 dash are connected in parallel, and they are asking to find the common potential. So we know that common potential V common is equals to Q1 plus Q2 by C1 plus C2. So Q1 plus Q2, 10,000 plus 1000, it will be 11,000. C1 value how much we have, that is C1 dash, C2 dash, new one we are basically trying to find. 100 plus 100 will be 200. Zeros will get cancelled. 110 by 2, which will be 55. So common potential will be 55 volt, which will be the final answer.